Good evening, dear and esteemed learners. Welcome to Black Slides Online Secondary School. My name is Mr. Poch Lola. I represent Black Slides here in Malawi. Our main emphasis, which is our niche, is to teach MSCE Sciences and the other subjects too. We invite you to subscribe to the channel so that every time we upload a new video lesson, you are informed. If you are on our learning platform, which is Black Slides Online Secondary School platform, kindly download the notes which are posted there and answer the questions that are posted under each video lesson. And remember to share your answers to me so that we discuss your answers. Where need be, we do corrections. So without further ado, let's proceed with the lesson of the day. We are exploring the effects of temperature, humidity, and the air pressure. Shall go in that order. How does temperature affect the speed of sound in air? Remember that sound is a longitudinal wave and it's a mechanical wave, okay? That means it travels through matter, such as solids, liquids, and gases, as well as in air. So we are going to look at how each of these factors affects the speed of sound in air. How does temperature affect the speed of sound? First, let's understand that sound is a longitudinal wave that travels through a medium, like air, by vibrating air particles. And also recall that sound travels in what we call compressions and rarefactions. Sound waves are carried from one place to another by the vibration of particles. First, the vibration of the particles of the source of the sound, and then the vibration of the air particles. So it is through the vibration of the particles that sound is propagated to your ears for you to hear it. So recall that sound is a longitudinal wave, right? Meaning that the particles vibrate in the direction parallel to the direction of the wave itself. That's why we say sound is a longitudinal wave. Remember also that temperature is a measure of the average kinetic energy, which has to do with movement of particles in a substance, such that when temperature is low, particles move slowly, and when temperature is high, particles move faster. So in explaining the effect of temperature on the speed of sound in air, there are two key points that you must raise. According to the kinetic theory of matter, which you learned already in Form 3, as temperature increases, air molecules gain more kinetic energy. This point alone is 1 mark. So you say as temperature increases, air molecules gain more kinetic energy. Kinetic energy is energy of motion of particles. Due to the increase in the kinetic energy, molecules move faster. And as they move faster, they collide more frequently with each other, causing sound to travel faster in warmer air than in cooler air. So we can conclude on that basis that higher temperature leads to higher speed of sound. So when temperature increases, speed of sound in air also increases. Why? Because as temperature increases, air molecules gain kinetic energy, more kinetic energy, which causes the particles to move faster and to collide more frequently with each other. Therefore, sound travels faster in warmer air than in cooler air. So you have 4 marks for raising these points together. You have 1 mark for the first point by saying that as when temperature increases, air molecules gain more kinetic energy. That's 1 mark. By saying molecules move faster and collide more frequently with each other, that's another mark. That's 2 marks together. Sound travels faster in warmer air, that's another point. So you conclude by saying the higher the temperature, the higher the speed of sound. 4 points raised, 4 marks. Great. In case you have questions, don't hesitate to send us a text message. We shall be glad to respond to you in time. Right, so let's move on. Let's look at humidity. The effect of humidity. How does humidity affect the speed of sound in air? First of all, we need to understand what humidity is. Humidity refers to the amount of water vapor in the air. And remember that water vapor is gaseous water, which is H2O gas present in the air. It's called humidity. So when you say air is humid, it means that such air has moisture or water. We call it atmospheric water. It's called vapor. All right? So when humidity is low, air is dry. And when humidity is high, air is moist or wet. So dry air is mostly nitrogen gas, which has a mass of 28 grams molecular mass. Dry air is mostly nitrogen and oxygen. Okay, so when you compare the masses of nitrogen and oxygen, nitrogen molecule, which is N2, has a molecular mass of 28 grams, while oxygen has a molecular mass of 32. 32 is because one oxygen atom is 16 grams, therefore O2, which is one molecule of oxygen, is 32. That's 16 times 2. Similarly, nitrogen, one nitrogen atom has a mass of 14. Therefore, 2 atoms, which makes one molecule, has a mass of 28. That's 14 times 2. But consider the mass of a molecule of water. If you take one molecule of water, which is H2O, it has a mass of 18 grams only, which means that water vapor is lighter than nitrogen and oxygen together. Water vapor is only 18 grams. One molecule of water vapor is 18 grams, but oxygen molecule is 32 grams, and the nitrogen is 28 grams. So compared to 1 molecule of water is lighter than nitrogen and oxygen combined together. So, how does humidity affect the speed of sound in air? When humidity increases, some of the heavier nitrogen and oxygen molecules are replaced by lighter water molecules, water vapor molecules, so that the average mass of air becomes less or decreases. Why? Because lighter particles move more quickly. Okay? Therefore, sound travels faster in humidity than in dry air. So, moist air is less dense than dry air. So, the fact that moist air is less dense, it means its particles move faster, very faster compared to particles of air in dry air. Water vapor is lighter than oxygen and nitrogen combined together. So sound travels faster in less dense air, which is water vapor or moist air. All right? So the higher the humidity, the higher the speed of sound. You need to understand this. There's a confusion that arises from different physics teachers. Students in some cases are told that when humidity is high, speed is lower. That's not the case. When humidity is high, air becomes less dense. And because air is less dense, it means the particles will move faster and faster, carrying sound faster as far as possible. Therefore, sound travels faster in humid air, wet air than in dry air. So the higher the humidity, the higher the speed of sound. You are going to be asked by Mane to explain how humidity affects the speed of sound in air. Moist air is less dense than dry air, right? For that reason, it means the air is going to travel very, very fast, or faster compared to dry air. Therefore, when humidity increases, speed of sound increases. Please go through this a number of times until you are sure that moist air, or when humidity is high, air becomes lighter. Therefore, it travels faster. Right? It carries sound much, much faster than dry air. Lastly, another factor that affects the speed of sound in air is air pressure. When discussing the effect of air pressure, we have to assume that temperature is constant. Otherwise, it will be confusing. If temperature is changing and air pressure is also changing, it is difficult to tell which is causing the increase or the decrease in pressure. In sound, speed of sound. When temperature is constant, changes in air pressure do not significantly change air density. So density stays the same, so the speed of sound is almost unchanged. Conclusion: pressure has no effect. Air pressure has no effect or little effect on the sound, the speed of sound. Understand that at the constant temperature, pressure does not affect the speed of sound. All right? When temperature is constant, changes in air pressure do not significantly change air density. Therefore, density stays the same, near the same, and the speed of sound is almost unchanged. So the conclusion is air pressure has no or little effect on the speed of sound. All right, but if the temperature of the air changes, the density of the air molecules will also change. Therefore, the air pressure will also change. Therefore, at that point, speed of sound in air is going to be affected to some extent. All right, in case you have questions, don't hesitate to come back to me. I'll be glad to explain what I might not have explained properly. My name once again is Mr. Chipo Chilola. Welcome. See you next time. Bye-bye.